Hello there everyone, this is Zenith and today we'll be doing physics paper 1 multiple choice 9702 variant 2 paper 1. This is February March 2022. So let's get started. Question 1. What could not be a measurement of a physical quantity? Alright, so let's see. The first unit is 10K. K is for the kelvins, this is for temperature, that is a physical quantity. Then we have on the other hand side 25 terameters. Terameter, again, that's a unit for distance. Then let's look at the middle two units, which are quite awkward. They're an amalgamation of units basically, but we can simplify them. Let's start from the option B, joules per Newton per meter. So what is joules? A joule is equals to force into distance. Formula if you use, that means it could be equal to joules is equals to the Newton meter. And then if we simplify this Newton meter, it's basically kg meter per second square into meter. And that would give us kg meter square per second square. So that's the unit we found for joule. But let's now try multiplying it with the rest of the units. So we have joule, Newton and meter. So we have kg meter square second inverse. Let's keep everything in the numerator. And we have multiplied it with inverse. So that means 1 over kg meter and per second square. So this again in numerator, that would be minus 2. And then lastly, we have again multiplied it with basically meter. And then you can see that when meter will multiply together, you will get meter square. That is actually the same unit as this. So this entire unit basically cancels out. So do you understand what's the problem? The problem over here is 11 has no units. It is just a constant. Let's look at this one, pascals per meter cubic per Newton. So what is pascals? Pascal is pressure, right? Pascals is equals to force per area, which means it is equals to Newton per meter square. Then let's just put Newton per meter square and multiply it with the rest of the units, which is meter cube and Newton. So these and these cancel out. By the way, this Newton is in the numerator. This and this Newton cancel out. 3 minus 2, you will get meter as your final unit, which means this entire unit over here simplifies to meters. Therefore, option C is also correct. So the one which we find wrong is the option B over here. Question 2. A computer memory stick is labeled as having a storage of capacity of 128 gigabytes. The letter B stands for a byte, which is unit. What is the equivalent storage capacity? Now this question is really easy for computer science students. However, if you aren't a computer science student, do not worry, because this question is also easy. First of all, what is a gigabyte? What is giga in general? Giga is 10 raised to power 9. This is basically 10 raised to power 9 GB. So what is the equivalent storage capacity? B stands for byte, which is a unit. What is the equivalent storage capacity for 128 gigabytes? All right. So basically 128 gigabytes is just 128 into 10 raised to power 9 bytes. As said, 10 raised to power 9 is the value for giga. But now we don't have an option of 9 over here. But they are using standard form over here. We will add extra units. When we go, the decimal is originally over here. When we go 2 places back, the power increases by 2 as well. 9, 10, 11. So we get 1.28 multiplied by 10 to the power 11 bytes. If you see here, the correct option is B. Question number 3. A man of mass 75.2 kg uses a set of weighing scales to measure his mass 3 times. He obtains the following readings. Which statement describes the precision and accuracy of the weighing scales? All right. So, what is precision? Precision is how close the values are to one another, and accuracy is how close are the values to the true value. If we subtract these values from one another, you will get an error of plus minus 0.1, which is actually the precision. Therefore, we can see which options do not apply to it. Not precise to plus minus 0.1, that's wrong. Not precise, again, that's wrong. It is precise to plus minus 0.1 kg, that is correct. And accurate, let's check for the accuracy. If you subtract 80.2 or 80 from 75.2, we will definitely not get 0.1. Therefore, it is not accurate to plus minus 0.1 kg, and the correct option is D. Question 4. Which statement about scalar and vector quantities is correct? Alright. A scalar quantity has direction but not magnitude. Absolutely wrong. A scalar quantity has magnitude but not direction. That is correct. Question 5. How can the acceleration of an object be determined? Alright. From the area under a displacement time graph? No. From the area under a velocity time graph? No. That is for distance. That's for finding displacement. From the gradient of a displacement time graph? No, that would give you velocity. Again, this option is wrong. From the gradient of a velocity time graph? That is correct. That gives you acceleration. Question 6. A sprinter takes a time of 11 seconds to run a 100-meter race. She first accelerates uniformly from rest, reaching a speed of 10 meters per second. She runs at a constant speed of 10 meters per second until the finish line. What is the uniform acceleration of the sprinter for the first part of the race? Alright, so we are suddenly just overwhelmed by a lot of information. The best thing you can do in such scenarios where you're given a lot of speeds, a lot of time and distance, the first thing you can do is try sketching a graph for the scenario if possible. In this case, it is possible. So what kind of graph? That depends on what kind of data do you have. We have velocity and time data. So we will be making a velocity time graph. Just sketching it, of course. Velocity time graph. Alright. The sprinter takes a time of 11 seconds to run a 100-meter race. Alright. She first accelerates uniformly from rest. Uniformly from rest means that the gradient line will be straight, reaching a speed of 10 meters per second. So this would be 10. And then she runs at a constant speed until the finish line. So it's a constant speed. Now, important thing to notice over here is this whole area under the graph is equals to 100 meters, because the area under a velocity time graph is the displacement or the distance, which in this case we are already given as 100 meters. Now what they are asking us? They are asking us the uniform acceleration of the sprinter for the first part of the race, for this given part of the race. But the problem is that we do not know the time at this point. We know the time over here is 0 seconds, but we don't know the time here. We do know the final time, which is 11 seconds. So in this way, we can try making some sort of formula to understand what is the time at this point. Let's name it as t. We need to know the time at this point, because what is acceleration? Acceleration is final minus initial velocity over the time. Final was 10, initial was 0, but the time period we can't tell because we do not know the point at which she stopped accelerating uniformly. So let's construct an equation for this question. We know the distance is 100 meters, which we can make it equal to the shape which is making the underside of the graph. We have a triangle over here that would be 1 by 2 base into height. What was the base? The base was from 0 to t, which is basically t, and the height is 10. That's the triangle part. For the rectangular part, the length was 11 minus t seconds, because it is just covering this distance. And the height again, of course, is 10. When you simplify and solve, let us see. 100 equals to 0.5, 10 plus 11 minus t into 10. So putting this in the calculator, we will get our t value as 2 seconds. Now that's just the t value. We didn't find acceleration yet, but now we can find it. Final value of velocity was 10, initial was 0, over the time 2, and we get our acceleration as 5 meters per second square. So the option is D. All right. Question number 7. A single horizontal force is applied to a block X which is in contact with a separate block Y as shown. The blocks remain in contact as they accelerate along a horizontal frictional surface. A resistance is negligible. X has a greater mass than Y. Which statement is correct? Alright. So when they have said to us that X has a greater mass than Y, the first thing you should do over here is that assign an arbitrary value to X and Y of mass. Just to make our calculations easier, just assume any mass that applies to the question. In this case, X has a greater mass. Let's make the mass of X as 2 something, 2 kilograms, and of Y 1. It doesn't matter what units, but what matters is that X must have a greater mass. So let's see the statements one by one. Acceleration of X is equal to the force F divided by the mass of X. That isn't exactly right. What the question said, the blocks remain in contact as they accelerate along a horizontal frictional force. If we make an equation for this, and by the way, F, the net force, will be equal to just F. There is no resistive forces because they said frictionless with no air resistance. So the net force would be F, and we will use the equation F is equals to M into A. In this case, M was X plus Y. And acceleration, both of them experience the same. Now we said that the acceleration, or that the mass of X we assumed as 2 something. So we can say that for X we had 2A, and for Y we just had A. This is the force on Y, this is the force on X. The acceleration of X is equal to the force F divided by the mass of X. That is wrong. Acceleration X is equal to force F divided by mass of X. That's wrong because you're also considering the mass Y in this equation. If it would have been F is equals to the mass of X, which would have been something like, as said, 2A, then this equation, then the option A would have made sense. Otherwise, no. For this question, this option does not make sense. The first option is wrong. Option B, the force that X exerts on Y is equal to F. Again, that is wrong. If you rearrange the force that X exerts on Y, if you rearrange, or even if you don't rearrange actually, you can see that F is basically split into two parts, force acting on the Y block and force acting on the X block. It is not equal to F. Now let's see. The force that X exerts on Y is less than F. That's absolutely correct. Both 2A and A should be less than F so that when they add up, they will equal F. This option is definitely correct. The force that X exerts on Y is less than the force that Y exerts on X. Again, that is wrong. What did they say? Force that X exerts on Y is less. That is absolutely wrong due to one big reason, that the mass of X is greater. In the equation of F equals to ma, we can clearly see that the force is directly proportional to mass. So if X has a greater mass, it will exert a greater force on Y. The correct option is C. Question 8. A car of mass 750 kg has a horizontal driving force of 2 kilonewtons acting on it. It has a forward horizontal acceleration of 2 meters per second square. What is the resistive force acting horizontally? We can use the equation F net force is equals to mass into acceleration. F is equals to ma. In this case, the forward driving force was 2000 newtons or 2 kilonewtons minus the resistive force, because they have said that there is some sort of resistive force acting on it. We're gonna call it as F resistive force, Fr. Mass was 750, acceleration was 2. When we will rearrange and solve for Fr, let's do it in a calculator. 2000 minus Fr into 7 equals to 750 into 2. We get our answer as 500 newtons. But be careful, this is not your final answer, because you need to also then divide it by 1000 and you will get your answer as 0.5 kilonewtons. So we can see the correct answer is option A. Question 9. An object falls freely from rest in a vacuum. The graph shows the variation with time t of the velocity v of the graph. Which graph using the same scales represents the object falling in air? Alright, let's consider each option one by one. Now, why the graph is straight, you might wonder, for a free falling object. Usually for a free falling object, acceleration starts as 9.81 always, and then it slowly gets to 0. But that's only the case when you have an object that is falling with some weight and it has some air resistance acting on it to balance it. In the vacuum, that's not present, and therefore you have the straight acceleration of 9.81 meter per second square. But now they've said that it is falling in air. Therefore, the first option will definitely be wrong. Acceleration will be equal to 0 after some time. It will reach terminal velocity. Second graph does make sense. It is correct. But they have highlighted this in bold using the same scales. Velocity will actually be less. It will start at 9.81, but it will level off very quickly. It will not just reach the maximum speed. You could even work with some sort of values and see that option B will not make any sense. They have said using the same scales 9.81, and it also started as 9.81, but the problem with this was that it is getting to a very high speed, which is wrong. It does level off at a lower speed. It just won't go all the way to the top. Option C is definitely correct. D is just wrong. The graph should level off, not just increase in gradient. Option B would have been in fact correct if they would have said using the same, if they would have said just say the graph shape. Using the same scale mean that the speed just can't be maximum. It did reach maximum if it was in a vacuum, but with air you can't just reach maximum speed. Some of the kinetic energy will transfer to the air. Question 10. A rock of mass 2m is traveling in deep space at velocity v, explodes into two parts of equal mass, one of which is then stationary. What is the kinetic energy of the moving part after the explosion? Alright, so we are not given all of the information, the first thing we have to notice. But we can work with momentum. What we have been given, let's work with the initial mass. Let us just say mass initial was 2m. And its initial velocity vi was v. Then after it, we had new data, which was explodes into two parts of equal mass. Therefore, we have now two masses, one of which is then stationary, and then they have said that one of them have a velocity of 0, other has some sort of velocity that we need to find. What is the kinetic energy of the moving part after the explosion? We do not know because we do not know the velocity. So we have been given this data. We can work out this using conservation of momentum. So conservation of momentum states that initial momentum of the object must equal the final momentum of the object. What was the initial momentum? Initial momentum was the mass into velocity 2mv. Final momentum was m into 0. One of the masses are not moving. They set into two parts of equal mass. So we're going to assume it as just m and m, which makes equal sense because this was the mass divided by 2. You get m as one of the masses if you equally divide it. That was one of the objects, which of course wasn't moving, so we just entirely remove it from our calculation. But then we have the other mass and we have some velocity with it. I'm gonna name it vf because we do not know the velocity. M and m cancels out, so we are left with 2v is equals to v final, or the velocity of the object which was moving. Now we have to find the kinetic energy of the moving part after the explosion. So what is kinetic energy? Kinetic energy is 1 by 2 mv square. M will remain as it is because the mass was m. V square, make sure 2 and v are in the square, will be then 2 into 2 raised to power 2, that would be 4. So you would have 1 by 2 m into 2 raised to power 2 4 v square. 2 ones are 2, 2 2s are 4, and in the end you'll be left with 2mv square as your final answer, and that means that option D is the correct answer. Question 11. A horizontal metal bar PQ of length 50 cm is hinged at end P. The diagram shows the metal bar viewed from above. Two forces 16 Newton and 5 Newton are in the horizontal plane and act on end Q as shown. What is the resultant moment about P due to the two forces? So they have now asked us for the resultant moment, which means the combined effect of these two forces acting. Now the thing is, we can't work with these two forces directly. We need to make sure that we are working with perpendicular forces, because what is the formula of finding a moment? It is the perpendicular distance multiplied with the force. So we can find a perpendicular force instead of this force. How? By getting the y component of this force, which would be 16 sine 30. This would give us the force that is perpendicular to the pivot. And then we find the moments for these separately, and then we subtract them because they're in opposite directions, and we will get our final answer. So the resultant moment, I'm just going to call it m resultant. And let's see, it will be 16 sine 30 into 50, but make sure that we divide it by 100 first because we want it in meters, into 0.5 minus 50, not 50, 0.5 meters into 5 newtons. And then we can put this in our calculator and find the answer. That would be 16 sine 30 into 0.5 minus 0.5 into 5, and that would give us the final answer of 1.5 Newton meter. And that's our final answer, A. Question 12. A cube WXZY has sides of length 2 cm and mass 24 grams. The cube rests on a meter rule of negligible mass. The geometrical center of the cube is vertically above the 70 cm mark on the scale of the rule. The cube has a non-uniform density so that its center of gravity is not at its geometrical center. The center of gravity of the cube is in the plane of the diagram. The rule rests on a pivot at the 50 centimeter mark. A mass of 23.4 grams placed vertically above the 30 centimeter mark. The rule is horizontal and in equilibrium. What can be determined about the position of the center of gravity of the cube? Alright, so they've said to us that the center of gravity of the cube is not in the center. Usually it would be in center if the object is uniform, but in this case it isn't. So the center of gravity could be anywhere, here, 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 here. We do not know, but we know one thing, that is these two objects are balanced, and we know that the center of gravity of this object is directly acting at the 30 centimeter mark. Then there is a center of gravity somewhere over here that is giving a force on that meter rule mark, that is balancing the moment caused by the mass of 23.4 grams. That's one thing we can work out. So usually we would find moment as the force into distance, but in this case the 9.81 from both sides would cancel out if we put it into the momentum equation. So let's do it. Anti-clockwise momentum must equal the clockwise momentum, as this whole system is in equilibrium. That would be 23.4 grams into 50 minus 30. Very important, it's not 30 meters from the pivot, it's 50 minus 30 meters from the pivot. And you could also multiply 9.81 with the grams, the kilograms, to make it into a force, but 9.81 would just cancel out on both left hand and right hand sides, so it's not worth doing that. So on the other hand side, we have 24 multiplied with 69. Let us start with one of the sides, 69 minus 50. You could also start with 71 and then work out, but I'll be doing it from the 69 point. Or actually no, we do not know the exact point. The exact point, let's name it as x. X is some point which we need to find out. x minus 50. So let's put this in our calculator. 23.4 into 50 minus 30, 24 x minus 50, and we get our answer of x as 69.5 centimeters. That means that it is just at a distance of zero point 0.5 from the 69th mark. So now let's see the options. It must be somewhere along. What can be determined about the position of the center of gravity of the cube? It must be somewhere along a horizontal line that is 0.5 centimeter from wx. That is wrong. 0.5 from the line wx means that we're saying it is somewhere on the top over here. We never said that. We said it is at the 0.5 centimeter mark from the 69th mark. So that is very much far from wx. The first option is obviously wrong. The next option, it must be somewhere along a horizontal line that is 0.5 centimeter from the line YZ. Now they are using it in the opposite way. They're saying it is somewhere from this point. Well, again, that is wrong. We do not know if it could be up or down in this line. But one thing we know for sure, it could be somewhere at the 0.5 mark, but it's not at all in the line YZ. It is at one mark, which is 69.5. So it's not all along YZ, it's at the 69.5 mark. We know that. So again, option B is also wrong. It must be somewhere along a vertical line that is 0.5 centimeters from the line WY. If you look again, this is absolutely correct. 69.5 minus 69 is 0.5 centimeters. It is at some line which is 0.5 from WY. So this option is definitely correct. Option D, it must be somewhere along a vertical line from XZ. Again, that is wrong. They're measuring it from 71. 0.5 from 71 backwards. That is absolutely wrong. Again, it's at 69.5, not at the 0.5 from 71. So option D is also wrong. Option C finally is correct. Question 13. A rigid sphere is held at rest on the seabed. When the sphere is released, it rises to the surface of the sea. The seawater has uniform density. Which statement about the sphere from its release until it reaches the surface is correct? Alright, so they're saying that a sphere is at the bottom of the sea. And now they have released it, and then they have said that what is true about the sphere up until the point that it has just touched the surface. Note the fact, just touched and not gone above it, not at all. So we're not considering that situation. So what can we conclude from this? They've said from the seabed all the way to the point where it is just touching the surface. Well, if we look back at the formulas, first of all, let's read the options. The sphere always moves with constant acceleration. No. The sphere always moves with constant velocity. Again, that is wrong. The upthrust on the sphere always decreases. About the upthrust, let us see. For constant velocity and constant acceleration, that is definitely not correct. The force acting on this is not really matching with the acceleration and the velocity. But if you are really unsure about this, try working from the upthrust options, because they also have something to tell. So first of all, let us see what's the formula for upthrust. Upthrust is the density into gravitational force into the submerged volume. Most importantly, submerged volume. So we know density and gravitational force are constant. What about volume? Submerged volume in this case was V, which is the entire sphere. In this case, it is also V, which is the entire sphere. So we can see that V was also constant up until the point it reached the surface. That means that upthrust must also be constant, because the entire time volume, which is the only variable that could vary, is also constant. The volume submerged under the surface. Therefore, option C is definitely wrong. So option D is correct. Question 14. What is the unit for density? Let's see. Newton. Newton definitely can't come in density. It is kg per meter cubic. Gram per millimeter inverse, that's again wrong. Millimeter inverse, where is the cubic? Same goes for option C. There is no cube value. There is a cube value over here, and also because it's the last correct option, option D is correct, because it has, first of all, a value that is the mass and a value that is a volume. Cubic you can see over here. Option D for question 14 is correct. Question 15. The total energy input E in is in a process partly transferred to useful energy output Q and partly transferred to energy that is wasted W. What is the efficiency of the process? All right. Efficiency E is equals to the useful energy. In this case, useful energy is U over the total energy. Total energy in this case was E input multiplied by 100. That's the percentage efficiency. So option A obviously is correct. Question 16. An escalator is 60 meters long and lifts passengers through a vertical height of 30 meters as shown. To drive the escalator against the forces of friction when there are no passengers requires a power of 2 kilowatts. The escalator used by passengers of average mass 60 kilograms and the power to overcome friction remains constant. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meter second? Alright, so let us see exactly what they're asking us. They're asking us how much power is required to drive the escalator when there are 20 passengers on it. So, what kind of power exactly? Well, when the passengers are going up the escalator, there are two kinds of power acting on them. The power done for against gravity and against the force of friction, of course, because they're on the escalator. So, for power that was against the force of friction, that will be actually 2 kilowatts, because they have said that for the whole period of them going up the escalator, the speed of the escalator was constant, and whenever speed is constant, the power against friction will equal to the power which the passengers are trying to overcome. So frictional power that will remain constant 2 kilowatts. Same would be the force which the passengers are exerting against the frictional force. So that 2 kilowatt is done, but that's not the only power that will be done by the passengers when they're going up the escalator. They're also doing some sort of power against gravity, which is again what? Power is work done per time taken. But in this case, we do not know what is time. But there is another formula for power, that is force in the direction of velocity. So we can work out that. But the first thing we need to know is velocity. Force, of course, we will know that will just be 20 multiplied with mass into gravity. That would give us the force due to the weight of the 20 passengers. But we do not know what's the velocity. And we know gravity always acts downwards. So we need to find some force, we need to find some velocity that is also acting in that plane. Doesn't matter upwards or downwards, but it must be acting in that plane. Currently, the passengers are traveling at 0.75 meter per second, but at a tilted direction. Note that the 0.75 is like this. So we can find the vertical component for this, but we do not have any angle. Our angle in this case is missing, but we as well can find out that. How? If you look closely, we have two values given over here: 60 meters, the length of the escalator, and 30 meters, which is the height covered. We can definitely find out this angle theta, and that will be by the opposite over hypotenuse sine. So sine theta is equals to opposite 30 or hypotenuse 60. This would give us theta, that is 30 degrees. So 30 degrees is our angle here and 30 degrees is our angle also over here. Now we can find the vertical component of our speed. So what is our vertical component of speed? Our vertical component of speed is 0.75 sine 30. So 0.75 sine 30 gives us 0.75. Now we have found the velocity in the direction of the force. Let's calculate the force now. All right. So force is what? Weight. Weight is what? Mass into gravity. So 20, because it's 20 passenger, for each passenger we have to calculate 20 into mass, which is 60, into gravitational force, that is 9.81. Multiply this with the velocity, is 0.375. And with this we'll get the power. So let's see. It's 20 into 60 into 9.81 into 0.375. That gives our answer as 4414.5 watts. That is equals to 4.4 kilowatts. When we now combine both of these power, we're going to get the total power that is done to drive the escalator when it's carrying 20 passengers. So power total in this case would be 2 plus 4.4 kilowatts. That would give us 6.4 kilowatts as the final answer. So the correct answer is B. Question 17. A rock of mass 40 kg is released from rest from a height of 20 meters above the surface of a planet. The rock has no kinetic energy. The rock has a kinetic energy of 32 kilojoules when it hits the surface of the planet. The planet does not have an atmosphere. What is the weight of the rock on the surface of the planet? Alright. So they've used the word planet too many times. That means this is definitely not Earth. That means gravitational force or gravitational acceleration is not equals to 9.81. The next thing, the planet does not have an atmosphere. That means that we can apply the principle of conservation of energy, because there is no wasted energy in this case. There would be wasted energy if there would have been an atmosphere due to the air resistance. But there is no air resistance. That means we can say that the kinetic energy during this whole fall was equal to the gravitational potential energy. If we write their respective formula, that would be 1 by 2 mv square is equals to mgh. That would be mass cancelling out. But next we have two variables that we do not know. We have the velocity and we have gravity, which we do not know. We do have height, which is 20 meters per 20 meters. So let's calculate velocity first of all. So 32 was the kinetic energy. This would be equal to 1 by 2 into 40 kg into v square. V would be 40 meters per second. Now we have calculated V, that would be 1 by 2 into 40 squared. And then we have gravity into 20. Now let's calculate gravitational force. That would be 0.5 into 40 square equals to gravity into 20. That would give us the gravitational force of 40. Alright, so we calculated gravitational force as 40. Therefore, now we can find the weight. Weight is 40 kg into 40 meter per second square. 40 into 40, 16. We get the weight as 1600 newtons, which is equals to 1.6 kilo newtons. That's your final answer. Option C is correct. Question 18. A metal wire is stretched. The wire obeys Hooke's law. Which quantity has a value that does not change? Okay, let's see one by one. Extension definitely changes. Strain also changes. And stress also changes. The Young modulus, of course, doesn't change because it's a constant. Most importantly, it depends on the material itself. Young modulus will be constant for the material. The rest of the lists items over here will definitely change. Question 19. An object is stretched until it reaches the elastic limit. Which statement must describe the stress on the object when it is at the elastic limit? Option A, it is the maximum stress for which the object obeys Hooke's law. Well, this is not correct. When we sketch the graph of Hooke's law, it is something like this. Then it comes to a curve. Somewhere over here is the limit of proportionality, we'll call it L. And the elastic limit is usually above the limit of proportionality. Therefore, it is not the maximum stress because we have already gone above Hooke's law when we have reached elastic limit. So it's not the maximum, we have already bypassed it. A is not the option. It's the maximum stress that can be applied to object before it has elastic deformation. No, elastic limit is the maximum limit at which the object is stretching elastically. So of course option B is also wrong. Option C, it is the maximum stress that can be applied to the object before it has plastic deformation. That does make sense because elastic limit from the word itself means that beyond this, the object would not have any further stretch ability. Option D, it's the maximum stress that the object can withstand before it breaks. That's not exactly true. That varies for objects. It is different for a rubber band, it's different for a bar of steel. Option C makes the most sense. Question 20. Which statement about progressive waves is correct? They are always transverse wave. No. There are also longitudinal waves. They can exist in solids but not in liquids. No. They travel in all the mediums except vacuum. They decrease in frequency as their speed increases. No. That does not again make sense. Velocity is equals to frequency into lambda. If the frequency is decreasing, then velocity will also decrease, directly proportional. So option C is also wrong. Option D, the transfer energy away from the source. That is true. They transfer energy but not matter. Question 21. A cathode ray oscilloscope CRO is used to determine the frequency of a sound wave. Diagram shows the waveform on the screen. The time-based setting is 5 millisecond per division. What is the best estimate for the frequency of the sound wave? Alright. The time-based setting. What is the time-based setting? Time-based setting basically means that each division is 5 millisecond long. Now they've asked us for frequency. What is frequency? Frequency is equals to 1 over time period, as that's the only information that we can get from this entire question. What is time period? Time period is the time taken for one wave to complete. Alright, so let us see how much time does it take for one wave to complete. Now if you look closely, we can calculate, or we can see how does one wave, or how many boxes does one wave take, because then only we can find out the time period. But the problem here is that if you measure from crest to crest, none of the crests are exactly on point. Similarly is the case for the troughs. They are not exactly on point and we cannot get an accurate value of how many boxes does one wave cover. But let's see with one crest and one trough. Just one crest and one trough is not enough. It's ending in this point, which is again making us unsure how many boxes does it cover. Let's go a second wave. 1, 2, again we do not know how much boxes have been covered. Let's take another one and let's stop right here because we exactly can see how many boxes are covered over here. This makes the number of waves 1, 2 and 0.5 for just one crest. And how many boxes do they cover? 1, 2, 3, 4, 5, 6, 7. So how many boxes does one wave will cover? If it's a bit too complicated to wrap your head around, we can make it in this way. If 2.5 waves cover how many divisions? 1, 2, 3, 4, 5, 6, 7. 7 divisions. If 2.5 waves cover 7 divisions, how many waves or how much divisions will one wave cover? The x number of divisions. So obviously from this you can see that we are going to find x. You can either directly put this in your calculator, but in this case x is 2.8. 2.8 boxes or 2.8 divisions are covered by one wave. All right, so what is now the time period? So you can see that if we multiply this div with this div, it's gonna cancel out, and that's exactly what we want, because we want to get a unit in seconds, or a time unit basically, in order to get the time period. So to get the time period, we're just going to multiply time taken for one wave and the time base second, the number of divisions covering one wave and the time base setting, which is 5 millisecond. Div cancel, and in the end we get 5 into 2.8. So the answer we get is 14 millisecond. But 14 millisecond is not the value which we want to go after, because all of the values over here are given in hertz. And what is hertz? Hertz is wave per second. This is millisecond. So we're gonna divide this by 1000. So the answer that we will get is 0.014. 0.014. That when we'll put it back into the original, f is equals to 1 over t, 0.014, we will get our frequency approximately equal to 71 hertz. And there you go, B is the correct answer. Question 22. The warning signal on an ambulance is a frequency of 600 hertz. The speed of sound is 330 meters per second. The ambulance is traveling with a constant velocity of 25 meters per second towards an observer. The ambulance passes and then moves away from the observer with no change in velocity. What overall change in observed frequency takes place between the times at which the ambulance is a long way behind the observer and when it is a long way in front of the observer? Alright, so they are basically asking us for the overall change of the frequency at this point and frequency at this point. This question will use the Doppler equation, and if you do not know what's the Doppler equation, you can refer back to the very first page. And over here, you're going to find the formula for Doppler effect, which is F observed frequency is equals to Fs, which is the frequency of the source into velocity of the waves in the medium over velocity of the waves in the medium plus minus the velocity of the source itself. So let's go back to the original question and let's find this F1 and then we'll find F2. F1, which is the observed frequency for this one, is the frequency Fs into V over V plus minus V of the source. So what is this frequency of the source? The frequency of the source is 600 hertz into the speed of sound in the medium 330 in this as well. And now how will you decide whether it is plus or minus for this equation, because you have to use one of the symbols, not both of them? Well, if you do not understand which one to use, just remember that when the object which is creating the sound is traveling towards the observer, the frequency will increase. Why? Because all the waves at the front will be squished together. So the wavelength will decrease. If wavelength decreases, then frequency will increase. The observed frequency will be higher. And if it will be higher, that means denominator must be of course larger. Denominator must be of course smaller. If it will be smaller, only then we'll get a higher observed frequency. So in this case, 330 minus constant velocity, which is 25. And then we can put this in the calculator. 600 into 330 over 330 minus 25. And we get our answer as approximately 649. That's F1. Let's calculate F2. 600 into 330 over 330 plus 25. We have already done with the minus, obviously with the plus now we're going to do. And that is going to give us 557.7. Or 557 is also enough. Now this is not the final answer. Final answer is overall change in observed frequency. So the frequency changed from here to here. What is that change in frequency? Simply subtracting both of them. So 649 minus 557 will give you 91. So 91 is your final answer, which is option C. Question 23. Brief pulses of red, blue and green light are emitted from the sun at the same time. The pulses travel at the same distance to reach Mars. Assume that the pulses travel in a vacuum for the full duration of the journey. In which order will these pulses arrive at Mars? The first thing you need to notice is not to get confused by the option, because these pulses are of light and light has a constant speed. Most importantly, they are traveling in a vacuum, so you don't need to worry about the change in any of the mediums. So you can consider all of these following options wrong and option A will be correct. All of them will arrive at the same time. It doesn't matter about the colors. The color will of course change the frequency, but still the wavelength would also change. And these changes in frequency and wavelength will make the speed of the light still constant. And therefore, because speed of the light is constant, all of them will also arrive at the same time. So option A is correct for question 23. Question 24. Two coherent progressive waves must two coherent progressive waves from different sources meet at a point. Which condition must be satisfied for there to be zero resultant amplitude at the point where the waves meet? Alright. Condition to be satisfied for there to be zero amplitude at the point where the waves meet. Let us suppose there is a wave traveling. For there to be zero amplitude after superimposing, let's have a second wave. So there are usually two conditions, and the two condition is that the two waves must be in complete antiphase. They must be in complete antiphase, and most importantly, their troughs and crests must exactly line up. So those are one of the two conditions. So let's now look at the options. The two waves must be emitted from the source of the same intensity. Nope, there is nothing about intensity to do here. The two wave must be in phase. I just said that it should not be in phase, it should be antiphase. Because if they would be in phase, suppose this is the wave and then there is another wave which is having some other amplitude, this is considered something in phase, but this would not give you a zero amplitude after finding the resultant wave. The two waves must be traveling in opposite directions. No, there is nothing about opposite directions to do with it, only about the phase and whether the crest and trough line up. Only these are the things which matter if there must be zero resultant amplitude. The two waves must have the same amplitude. Yes, that is correct. If they will have same amplitude, the magnitudes of amplitude will cancel out and you will get zero amplitude in the end. So option D is correct. Question 25. A corridor is 13.2 meter long and has closed doors that reflect sound at both ends. The speed of sound in the air in the corridor is 330 meter per second. What is the lowest frequency of the sound that could create a stationary wave in the corridor with the node halfway along it? So they're talking about stationary waves and they're asking of the lowest frequency. That means we need to go to the most basic stationary wave that we can make. All right. This means that we just cannot have a stationary wave that goes somewhere like this. This is not the lowest frequency that we can have. There is another way in which you can make the stationary wave, and it is like this, with a node in between. But even this configuration is wrong. Why is this configuration wrong? Because there are closed doors at this. If these would have been open doors, then this configuration of a stationary wave would have been correct, but this it isn't. Because these are closed doors, that means the door will also have a node. They must, because they won't have any vibrating particles. So then if you make the wave, it would be this stationary wave. And now we can see the lowest frequency. So how do we calculate the frequency? Well, first of all, we need to know the wavelength, because velocity or the speed of the wave that makes up the stationary wave, we're talking about one progressive wave, p is equals to f lambda. We know what's the velocity, 330. We know what's the wavelength, no, so we can't calculate the frequency. But we do know that the distance, and this is a fact that you must know, the distance between one node to another node is equals to half the wavelength. All right, and this entire 13.2 meters is having three nodes, but it is very obvious that if you half 13.2, you will be having two nodes. If we half 13.2, we will get 6.6. So let's just make a separate picture over here. Node here, node here, and the distance which we had just halved would be 6.6. And we had just said that this distance from one node to another node is equals to half the wavelength. Now we can equate them. Half wavelength is equals to 6.6. And if we multiply this, we will get 6.6 into 2, which is 13.2, which is the wavelength. This is one of the ways in which you could have calculated the wavelength. The other way is that if you notice in this, one wave is basically one crest and one trough. And because we just have one crest and one trough in this entire system of the stationary wave, 13.2 itself is the wavelength. 13.2 is the wavelength. 330 is the speed we know, frequency we need to find, and 13.2 is the wavelength. So we can now find frequency. That would be 330 divided by 13.2. That would give us the frequency as 25 hertz, which is option C. Question 26. Water waves of wavelength lambda are formed in a ripple tank. The waves are diffracted as they pass through a narrow gap of width d. D is greater than lambda. Which gap width and which wavelength will cause the largest decrease in the amount of diffraction? So they've now asked us for the largest decrease. For the largest decrease, there must be maximum difference between the gap width and the wavelength. The first thing is, because they've just given us a comparison value that d is greater than lambda, let us assume some values for d and lambda to make some calculations easier. Just like we did in the previous questions, let's assume d as 2 and lambda as 1. Any value, but make sure d is greater than lambda. Now let us see by plugging in the values for each of these. 1 by 2d would be 2, 0.5 into 2. That would basically be 1. Similarly for this lambda, it would be just 0.5. And if you subtract both of these, because we just said that to have the largest decrease, there must be the largest difference. So if you subtract these two values, you will get just a difference of 0.5. We can do the same thing for all the rest of the values. Let us do for option C first of all. So 2 into 2, that gives us 4 for the gap width over here. And then we have 1 by 2 over here. So 4 minus 1 by 2. That gives us a difference for this one as 3.5. Let's see for the other ones as well. For option B, let us see. Let's see for option B, which was 0.5 into 2, that is 1, minus 2 multiplied by 1. That will just give us the difference of 1 basically. Doesn't matter if it's minus 1, the difference is actually just 1. We can do the same thing for this 2 and 2, but we're going to get a low difference. For option D as well, we can look. That would be 2 into 2, 4. Similarly, for lambda, we can see it would be 2. If you subtract it, the difference which you would get would be again 2. So you can see that the greatest difference we're getting is for the option C, and therefore option C is correct. Question 27. Two loudspeakers X and Y emit sound waves that are in phase and of wavelength 0.75 meters. An observer O is able to stand anywhere on a straight line that passes through X and Y as shown. The observer stands at a point where the sound waves from X and Y meet in phase. Alright, what they have said to us? They have said to us that there are X sound waves, two loudspeakers X and Y emit sound waves that are in phase. That means whatever wave that Y is emitting, X must also be emitting it in phase. For 2 points to be in phase, their path difference must be an even number of lambda. And if they would be anti-phase, completely anti-phase, their path difference must be n plus 1 lambda. So let's see for this condition, because we have just seen that X and Y are in phase over here. And the in phase wave basically 0.75. So how can we find it? We can divide each of these distances by 0.75. If they are giving us a whole number n, that means they are in phase. So let us start with 3.5. 3.5 divided by 0.75 gives us 14 by 3. That is wrong. So the whole option A is wrong. Let's go for 2.75. For option B, that gives us 11 by 3. Again, that is wrong. Option B is also wrong. Then let's go for 2 in option C, and we get 8 by 3. That is again also wrong, not a whole number of n. Then we do for 1.5 and we get 2, which is correct. Option D is correct because it is 2. And now you might wonder, what do we do with this column? Now it might sound confusing, but this is used for the waves being completely out of phase. If you apply the same process for distances O and Y, you would see that option D would still be correct. Why? Because when you would divide 3.25 by 0.75, you would get 13 by 3. And 13 by 3 is basically 4 1 by 3. N plus 1 lambda means a odd number of waves. So it could be something like 2 1 by 2 lambda, but odd number of half waves. Odd number of half waves would give you antiphase. 2 1 by 2 lambda, or suppose 4 1 by 2 lambda. But if you look in this case, it is 4 1 by 3 lambda. And if you compare it, it's basically in decimal 4.3. 4 waves and zero point 0.3. Therefore, it is much closer to being in phase than it is out of phase. It's in a partial phase basically. So it's not completely out of phase and it's not completely in phase, but it is much closer to being in phase. But still, option D is correct because, of course, 1.5 value we got it correct. We got two whole number for this and therefore they're in phase. Simply choose option D for that. So the correct option is D. Question 28. Light of a single wavelength is incident normally on a diffraction grating. The resulting diffraction pattern is displayed on a screen. Which change makes the first orders of intensity maxima further apart from each other on the screen? First of all, let's write down the formula because we're talking about a diffraction grating. What is the formula for the diffraction grating? It is d sine theta is equals to n lambda. And we are talking about angles. They're saying which change makes the first orders of intensity maxima further apart. For being further apart, the angle which is between the first order maxima, this angle must increase. So we can arrange it in terms of sine theta, which would be n lambda over d. Now let's look at the options. Placing the screen closer to the diffraction grating. No, that does not make any difference because there is nothing about the distance to the diffraction grating. Option A is wrong. Option B, using a diffraction grating with less separation between the adjacent slits. Of course, this is correct because D is inversely proportional to sine theta. If D decreases, which is the distance between adjacent slits, sine theta would increase, which is basically the angle. Angle increases, so obviously option B is correct. Using light of shorter wavelength will not increase the angle because they're both directly proportional, the angle and the lambda. Option C, using a diffraction grating with more slits but keeping the same separation between, but of course then this option is also wrong because they've just said same separation between adjacent slits, which means D is still same, then the angle would also be same, that would make no change. Option B is correct. Question 29, for a current carrying wire, the current can be calculated using the equation shown I is equals to A and VQ. What is the meaning of N? The number of charge carriers in the wire, number of charge carriers multiplied by the volume of the wire, number of charge carriers per unit length of the wire, number of charge carriers per unit volume of the wire. N is basically number density. And then if you would be confused that what is exactly the unit, you can see A is what? A is basically the area, which is meter square. N must be number density. We do not know what is the unit, and A over I over here is the current. So we do not know what the unit of N. P is what? P is meter per second. And Q is what? Q is the average drift velocity. Or Q is no. Q is the fundamental charge. V is the average drift velocity. That is meter per second. Q is the elementary charge or the charge of the charge carriers, which is of course in coulombs. And then if you convert the coulombs into current, let us see, I is equals to Q over T. So Q in this case, which is the charge, is equals to amp into second. It is ampere second. So now we can work out the units. Why are we doing this working in the first place? Because we have just understood the number density is N. But over here they've not written number density and they're confusing us by the volume multiplied by length multiplied by all of that. So this might be confusing. So let's first of all try figuring out the units. The first thing we should notice is trying to simplify this. All right, so S and S cancels out. Over here, meter square we will have as meter cube into n into a, and a we also have over here. If we cancel out a here and we cancel out a over here, we are left with 0. Not 0 actually. Left with over here 1. We're just trying to make the equation homogeneous. So m cube into n. This would basically be 1 over m cube. And from here we can see that it is the number of charge carriers. That is one thing we know for sure. Number of charge carriers over what? Per unit volume, because meter cubic, not per unit length because it's not meter, and not multiplied because it is a fraction over here. Option D is correct. Question 30. The number of free electrons passing a point in 24 hours is 6 multiplied by 10 to the power 23. What is the average current in the wire? Alright, what is current? Current is equals to the charge per unit time. And over here, we have number of free electrons passing 6 multiplied by 10 to the power 23. Something very important to notice here, that this is the number of free electrons. This is not the charge. The charge, you're going to multiply it with the number of electrons, which is 1.6 multiplied 10 to the power minus 19 coulombs. Over the time, which won't be in hours, we need to convert it to seconds. 24 into 60 minutes into 60 seconds. We can then plug this in the calculator. We got 6 into 10 to the power 23 into 1.6 into 10 to the power minus 19, and 24 into 60, and we get our answer as 1.1 amps, and option B is the correct answer. All right. Question 31. In a circuit shown, lamp P is rated 250 watts, 250 volts, 50 watts, and a lamp Q is rated 250 watts, 50 volts, 200 watts. The two lamps are connected in series to a 250 volt power supply. Assume the resistance of each lamp remains constant. All right. Which statement most accurately describes what happens when the switch is closed? Now, do not just directly go for the options. There is one thing you must notice, that this 50 watts only apply if a voltage of 250 is passing through the lamp. Similarly, 200 watts is for lamp Q only and only if 250 volts is passing through Q. If the potential difference is 250 only, then it would be 200 watts. But you can see in this case that it is not exactly 250 for each of them, but instead it is being split. Now, how can we find how much voltage is passing for P and how much voltage is passing through Q? Basically, the potential differences through each of them. We can do this through another way. So we know that the resistance of each lamp remains constant. Therefore, we can use the formula P is equals to V square over R, because we know R is a value that is constant. Let us find that first before doing any further calculation. So let us find R for lamp P first of all. R for lamp P would be 250 volts squared over 50 watts. That would give us 1250 ohms. Similarly, for resistance of Q, it would be 250 squared for 200 watts. 200 watts only, not squared. That would be 250 squared over 200, and we would get our answer as 312.5. All right, so we have the resistances. Now we need to find the voltages passing through them. What can we do? We can use the resistances as fractions to the voltages. You could have also just calculated the current, but we could use the resistances as fractions. So voltage is directly proportional to resistance. So we can use the ratio of resistances basically to calculate the potential difference, or we could have just used the current. So let us see. The potential difference passing through P is the resistance of P over the total resistance 1250 plus 312.5, and this whole thing would be multiplied with the total voltage. And let's do it. 1250 over 1250 plus 312.5 multiplied by 250, and we get PD across the lamp P as 200 only, 200 volts. And simply we can then calculate for across Q, which is 250 minus 200, because obviously we've calculated one, the other one will just be subtracted because voltages in a series are shared. So 250 minus 200 would give us 50 volts across it. So we know that there is 50 volts passing across Q, and we have 200 volts passing across the lamp P. What's the next step? The next step is now to calculate the new power for each of these. If you now put the same formula into each of these, we can calculate the power for P. The power for P would be 200 volts squared over its resistance, which is 1250. We would get it as 32 watts. Similarly, if we would do it for Q, we would get as 8 watts. And then they're asking us which statement most accurately describes what happens when the switch is closed. Lamp P emits 4 times as much power as lamp Q. Now that is true, because 4 times as much as power as lamp Q, 8 multiplied by 4, that would be 32. That means the first option is correct. The last of the options are not correct, but do make sure that the power value will change. It's not that you would just use the same power value and use their ratios to find next of the options. So make sure that you first of all see whether the voltage across the component is changing, and according to that calculate the power. Question 32. Piece of wire has a length of 0.8 meters and a diameter of 5 multiplied into the power minus 4 meter. The IV characteristic of a wire is shown. What is the resistivity of the metal from which the wire is made? Alright. So what is the formula of resistance? Formula of resistance is the resistivity, which we can name it as this unit, L over the area. In this case we have diameter. So we need to find first of all the resistance, and we can find it. What is V equals to? V equals to IR. So V over I is equals to R. But in this case, the gradient of the graph is not V over I. It is I over V. I over V is basically 1 over R. So let's calculate what is I over V, the gradient. So I over V, let's take the highest value. So we have 5 amps over 10. 5 over 10. That is 0.5. But again, 0.5 is not the resistance. 0.5 is equals to 1 over R. And in this case, the resistance would be 1 over 0.5. The resistance is 2 ohms. Alright. So we have found the resistance, that is 2 ohms. We need to find the resistivity. We have the length is 0.8. Now make sure about the area. The area is for a wire, and a wire, assuming that it is perfectly like a cylinder, we are going to assume its cross-sectional area as a circle. The area of a circle is pi r square. And in this case, we have the diameter, which is 5 into 10 to the power minus 4. This whole thing will be divided by 2 because it's the diameter, not the radius, and will also be squared. This will be multiplied with pi, most importantly, and then we will calculate it. And when you will calculate it, you will get your approximate answer as 4.9 multiplied by 10 to the power minus 7 ohm meter. So option C is the correct answer. Question 33. 10 cells each of electromotive force 1.5 volts are connected together as shown. What is the combined EMF between terminals X and Y? Now be careful. Don't just assume all of these are connected in the connected in the correct order, that you would just multiply 10 with 1.5 and you would get the answer. That will give you, in fact, the wrong answer. Because if you look closely, these cells are connected in the same way. And then you have one cell which is connected in the other way. Therefore, to find the combined EMF, E, it would not be 10 multiplied by 1.5. Instead, it would be 9 multiplied by 1.5 minus 1, 1.5 cell. And if we put this into the calculator, 9 multiplied by 1.5 minus 1.5, we would get our answer as 12 volts. And 12 volts is the correct answer, which is option C. Question 34. A cell of EMF E and internal resistance R is connected to a variable resistor as shown. The resistance of the variable resistor is gradually increased from R to 3R. Which graph shows the variation of the potential difference PD across the internal resistance with the PDV across the variable resistor? Alright, complex question. The first thing we should do is see what values are we given, right? So one thing we need to assume, the current is same, that is flowing through the variable resistor and the internal resistor, because this is a series circuit, so we can assume this resistor as just any other normal resistor. Therefore current flowing through each of these are same. So let us make some equations. Small v is equals to I, which is the same, into R, and then we have capital V, which is equals to I, the same current, into uppercase R, in this case VR. So they are now asking us in terms of graphs. All right, so this might look confusing, but some of us may start by finding gradients. Gradients are a good way to work with graphs. If you are given any kind of graph question, the best thing you could do is start taking out the gradient and see if the question has something to do with the gradient of the value. But in this case, if you're going to find the gradient would be V over V. All right, and what is V over V? V over V is equals to I R over 3 IR. I and I cancel, R and R cancel. Why am I writing 3R? Because it has been gradually increased from R to 3R. So we have 1 by 3 as the ratio between the V and the uppercase V. So now let us see. So the gradient would be something like 1 by 3. We just know that's the ratio, by the way. So we can see all of them are starting at 0.5, which is understood because both of them had the same resistance. But then after that, how do we know that the ratio will be 1 by 3? Well, let us see by judging the last points of each graph. So let us see. This V over here is 0.75 and this V over here is 0.25. If you now divide 0.25 over 0.75, you would get the ratio as 1 by 3, which means the first graph itself is correct. Now if you look at the rest of the options, this is 0.25, this is also 0.25, that will give you 1 value. And then you can do the similar stuff for the other graphs and they would give you different values. But what we have concluded that option A is correct. They have just used E because we do not know the actual EMF. So the correct option for question 34 is A. Question 35. Each Kirchhoff's two laws presumes that some quantity is conserved. Which law states Kirchhoff's first law and names the quantity that is conserved? Alright. So what is Kirchhoff's first law? Kirchhoff's first law is about current. Therefore, it is not option C and it's not option D because they're talking about EMF. In the question, in the option A and option B, they're talking about currents. So the statements for A and B are correct. Now let's look at the quantity. Algebraic sum of currents into a junction is 0. This is conservation of charge, not energy. So option A is correct. Question 36. A cell has an electromotive force of 8 volts and negligible internal resistance. The cell forms part of a circuit as shown. The reading V1 is 4 volts and the reading V2 is also 4 volts. Alright. What is the resistance of R? So they said V2 is 4, V1 is 4. We can then, that means, compare this resistor with this system of resistors, because the PD across both of these is 4 and the PD across R is 4. We can't yet compare it because these are two resistors, that is one resistor. But we can find an equivalent resistance for this, which is 1 over R is equals to 1 over R effective is equals to 1 over 4 plus 1 over 4, which is the equation for finding the resistances in parallel resistors. We can write this using inverse indexes as well. So 4 inverse plus 4 inverse whole inverse, that would give us 4 inverse plus 4 inverse whole inverse, that would give us 2. So we have found that this whole system of resistors will basically be 2 ohms, and that means the resistance of R will also be 2 ohms, because the resistance of this R must also be 2 ohms in order to have 4 volts. If this had 4 volts for 2 ohms, this must also have 4 volts for 2 ohms. Therefore, option B is correct. Question 37. In the circuit shown, the cells have negligible internal resistance and the reading on the galvanometer is 0. What is the value of resistor R? Now, this might be the most trickiest question in the entire paper, but let us break it down step by step. So what do we have here? We have two circuits which are joined together using this loop over here, this part of the wire, which is having a galvanometer. Now, they have said that the galvanometer has a reading of 0. What does that mean? That means the current flowing through this is equals to 0 amps. Alright. Another thing to notice here is that we have three loops. We have this loop, and then we have this loop, and then we have this loop. It is important to identify these two things, the currents and whatever loops are in the circuit, because that's the best way to approach parallel circuits. And now they're asking us resistance of R. We cannot really work out resistance of R by just using 6 ohms here and 9 volts here, because we do not know the current itself. What we can do is try extracting out this middle loop over here and analyzing it first of all. So this middle loop has one 9 ohm resistor, and it has another resistor that is 6 ohms, and in the middle we have a galvanometer. Now the galvanometer says that the current is 0. Using Kirchhoff's second law, we have extracted a loop. And what does Kirchhoff's second law state? That in any loop of a circuit, the sum of the PDs is equals to the EMF, which means that the PD in this will now be shared. But how do we know the PD that is in the whole circuit? And by the way, because we have extracted this loop, this has also now become a series circuit. If there was a current of 0 in this, that means that there is a current of 0 amps inside this whole loop. But this is not exactly true, because this 9 ohms resistor is also part of this upper circuit, and this upper circuit does have a battery. Therefore, we cannot just say that this entire loop over here has 0 amps flowing through it, therefore it would have 0 PD. That's not exactly true. So how can we start by finding a current that flows through this 9 ohm resistor? Well, we know 4 volts over here, 3 ohms and 9 ohms are over here. We can use the ratio of the resistors over here to find the PD flowing through this first of all. And another thing to notice, the current in this is 0, which means that the potential difference across this, the potential difference basically across this 9 ohm resistor, which we'll name it as V, is equal to the potential difference across the 6 ohm resistor. And now you might say how? Well, let's consider the situation of the batteries. Suppose, let's just clear this out first of all. So we just said that ammeter has a current of 0. If the ammeter has a current of 0, that means that the voltage that flows through the ammeter or this galvanometer must also be 0. Considering this loop, let us work our way with this loop in the direction of the battery. Alright, so some of the battery goes here. We have 4 volts over here. 4 volts, the 3 ohm battery, how much does it consume? Let us calculate that through the resistances. So we have 3 ohms over 9 plus 3. We're using the ratio of the resistances to find how much PD is consumed by this 3 ohm resistor. Multiply by the total 4 and we would get 3 over 9 plus 3 into 4, we would get 1. So 1 volt is consumed by this. Remaining we have 3 volts. So we know 3 volts is going in this, and we know 3 volts is also going through this wire. Now 3 volts is going through this wire, but what did I just say early? That the PD across this galvanometer must be 0 volts because the current is also 0. But we have 3 volts flowing here. What does that mean? That there must be some potential difference flowing in the opposite direction that must have some magnitude which is equal to 3 volts. Only then these both will cancel out. The voltage coming from top to bottom and the voltage coming from bottom to top. If they will have the same magnitude, only then will they cancel out to give a voltage of 0. And then that would make sense because the galvanometer has a current of 0. How does this happen? If the potential difference across the 6 ohm and the 9 ohm resistor are the same. But even if you don't understand this, we just had worked out over here that 3 volts flows into the 9 ohm resistor. If 3 volts is flowing into this galvanometer, that means 3 volts will also be flowing through this 6 ohm resistor. That's one thing for sure. Because of this way we treated the junction here, we're also going to treat the junction over here in the same way. And that is how figure out one of the parts of how exactly we can find the amount of voltage or PD across the 6 ohm resistor. Alright, so we know 3 volts is across here and 3 volts is across here. Now we can calculate for R. So to calculate the resistance now, we know the voltage through this is 3 volts. So simply we can now subtract 9 from 3. 9 minus 3 volts. Get 6 volts. 6 volts passes through this resistor. And again, we can use the same ratio of resistor. Basically, we'll have the resistor of R over 6 plus R, as it's the total resistance, multiply by 9, or not multiply by 9, multiply by 6 actually, multiply by 9, yes, and it should be equal to 6. Alright, basically it would be like this. So we have R for R, again taking the ratio of the resistor, plus 6 as the total, multiply by 9, total voltage is equals to 6 volts. That is the PD across this. And if we rearrange and we solve for R, we are going to get our answer as 12 ohm. The answer is C. Once again, this question was a bit difficult to solve, but we can analyze this using very simple Kirchhoff's laws. The first thing you should notice is that there are 3 loops in this. Alright. The second thing you should notice that we have this central loop over here where we have the current of 0 amps. But then you would assume that 0 amps is going through 9 ohms and 6 ohms resistor, but that is again false because you have these batteries connected to them. Therefore, there will be some PD flowing through them or some current flowing through them. And how do you calculate that? You calculate that from their original circuits above. And when you will calculate those PDs, it would make sure, then you have to make sure that the PD of the other resistor is also equal, because again the voltages must also cancel out. P is equals to IR. Given whatever resistor, if the voltage will be 0, current will also be 0 given whatever resistor, because that will also be 0, of course. So there must be 3 volts flowing in opposite direction in this wire in order to have 0 volts. That's the way I understood this question. And genuinely, it was a difficult question, but of course, if you're going to go with basic concepts, making sure you're solving it using the loops, this question should be easy. So for question 37, option C of 12 ohms is the correct answer. Alright. Question 38. When alpha particles are directed at gold leaf, number 1, almost all alpha particles pass through without deflection. A few alpha particles are deviated through large angles. What are the reasons for these effects? Alright. Let us see for the first. So almost all alpha particles pass through without deflection. Alright. Most alpha particles have enough energy to pass right through the gold leaf. No, that has nothing to do with the energy. Almost all alpha particles pass through without deflection is because the nucleus is very tiny and the whole atom compared to the nucleus is very big. This is one of the reasons. Therefore, we look for the reason that nucleus was very small. So the gold nucleus is very small. Yes, that is correct. For number 2, few alpha particles are deviated through large angles. Alright, let us see. Gold is very dense, so few low, no, that has no relation with the question. A few alpha particles bounce off gold atoms. No, that is not about the deviation of large angles. Occasionally, the path of an alpha particle is close to a nucleus. Yes, that is true. And therefore, option C is the correct answer. A few of the options in the second row is also correct. Occasionally, an alpha particle experiences many small deflections in the same direction. No, that doesn't make sense. But because for the first reason we had the gold nucleus is very small, second one, occasionally the path of an alpha particle is close to nucleus, will also be correct. Option C overall is the correct answer. Question 39. A nucleus X is radioactive and decays into a nucleus Y. X and Y are isotopes of the same element. Which combination of particles could have been emitted during the decay process? Alright. So what they are saying, let us write this as a nuclide equation. X and Y are isotopes of the same element. Alright. So isotopes. What are isotopes? Isotopes are those elements that have different neutron numbers, but they have the same proton numbers. Let us assume the proton number Z. Alright. And the neutron number being A. This would have decayed to a nucleus Y, with the proton number being the same, but the nucleus will change. Let us name this as B. So can you notice what is the pattern over here? We need to have some other particles, of course, that will bring the proton number back but change the nucleon number. If the nucleon number changes while keeping the proton number same, that means we have got an isotope. So for this, we're going to look at the combination of particles. And we can think about this alpha particles as having 4 and 2 protons and 4 as the overall nucleon. That is the alpha particle, make sure. And for the beta particle, you must know which beta particles are we looking at. We are looking at the negative beta particles, not the positrons. And if it's the negative one, their nucleon number will always be 0 for the beta particle negative, and the proton number will be -1 because it is a fast moving electron. So from this pattern, we can notice that if an alpha particle is emitted, the original nucleus basically loses 2 protons. Now, how do we get those 2 protons back? By having 2 beta particles released, because a negative beta particle is released when a neutron splits into a proton and a fast moving electron. And because of this electron, there is a proton in the original nucleus being formed. So if an alpha particle is released followed by 2 releases of beta particles, that means we get back to the original proton number. Doesn't matter if the nucleon number changed, because we do want it to change. That means that the nucleus has changed in terms of only the neutrons. So let's look for this kind of configuration. One alpha particle and one beta particle, not enough at all. That means Two protons have been taken out, but only one has been returned. One alpha particle, two beta particles. That makes sense. Option B is the correct answer. Why? Because one alpha particle, two protons have been taken out. Two beta particles, two protons have been put back. So option B is the correct answer. We can disregard all of the next option. Question 40. A positively charged meson consists of a quark and an antiquark. What could be the quark and the antiquark? Alright. So first of all, what you should know for this question number 40. You should know the charges on all of the quarks. So for the up quark, we have 2 by 3. For the down quark, we have minus 1 by 3. For the charm, we have 2 by 3. And then for the strange, we have minus 1 by 3. Then for the top quark, we have 2 by 3. And for the bottom quark, finally, we have minus 1 by 3. And now let's look at the combinations. A charm and an anti-up. What does that mean? A charm is 2 by 3. An anti-up is opposite of the up. If you look here, up is 2 by 3. Opposite of that is minus 2 by 3. So that just simply gives us 0. 0 is not a positive charge. It must be some sort of positive charge. Doesn't matter what number, but it can't be 0. Now let's look at the down and the anti-top. Down and the anti-top means minus 1 by 3 charge compared with the anti-top. Top was 2 by 3, anti-top will be minus 2 by 3. Again, that is wrong because we're just getting a whole negative charge. A strange and anti-bottom. Strange and anti-bottom, let's see. Minus 1 by 3 plus anti-bottom, which is plus 2 by 3. What do we get? Minus 1 over 3 plus 2 over 3. We get 1 over 3. Alright, that is one positive charge. Let's look up the up and the anti-strange. So up is 2 by 3 and the anti-strange is plus 1 by 3. So we get 2 over 3 plus 1 over 3 and we get the positive charge of 1. In this case, you have two positively charged basically mesons. But we are now confused between whether if it is this strange one and the anti-bottom, which is basically minus 1 by 3 plus 2 by 3 plus 1 by 3. Actually, oh yes, strange is minus 1 by 3. They said anti-bottom, so anti-bottom would actually plus 1 by 3. Alright, so it would again give a configuration of 0. 0 again is not what we are looking for because it's giving us a 0 charge. That's not what we want. We want a positive charge. Finally, we come up with option D as the correct answer because when you combine its charges, you're going to get 1. 1 is a positive charge for sure. And that is the correct answer for question number 40. This was the physics paper done. I hope you had understood. Please subscribe, leave a like, and do comment if you did not understand any question. And I will see you in the next one. Goodbye.